Okay, what's up? It's your old pal, Mr. Cook. We're working on the second page of the quiz review for Unit 2. So the first thing that we need to do is find all of the zeros, state the multiplicity, and if the zero touches or crosses the axis. So finding the zeros is really easy. All that you need to do is set each of the factors, each of the parts that are in parentheses or the parts that are multiplying out front, like if you had an x or an x squared or something, we set each of those parts equal to 0. And then solve for our zero values. Because zeros, it's really just a fancy way to say that we have an x-intercept. So the y value gets us 0 ultimately. All right, so 1 0 that we have can be found from the x. 1 0 that we have can be found from the 5x minus 2. And 1 0 that we have can be found from x plus 2. Each of these factors of the polynomial have to be set equal to 0 so that we can solve for the zeros. So for example, if we have x, we say x is equal to 0 for the first part. For the second factor, we have 5x minus 2 equals 0 for the second part. And then x plus 2 equals 0 for the third part of the polynomial. So x equals 0 is already solved. X equals 0. It's already done. We already know one of the solutions for it. So now let's go ahead and state the multiplicity. The multiplicity means that what we're looking for are any powers on each of the factors. So if we have a power of 1 on this x, it has a multiplicity of 1. So there's our 0 and also its multiplicity. Let's solve for the 0 that we have here with 5x minus 2 equals 0. So we add 2 to both sides. That gives us 5x is equal to 2. We divide both sides by 5, and that gives us our 0, which is 2 over 5, or 2/5. Now we're going to state the multiplicity. So we look around the parentheses. There's no exponent on there, so that means that it just has a multiplicity of 1. All right, now we move on to the next one, x plus 2. So we set that equal to 0 and solve. If we subtract 2 from both sides, we get our last 0, negative 2. And the exponent on this factor is also going to be 1, so it has a multiplicity of 1. So that's our number 11. Let's go ahead and do number 12 next, because it's the exact same rules that we're working on here. So here are our factors. One factor is at x to the third, one is going to be 2x minus 3, and the last one is going to be x minus 2. All of these individual formulas give us a factor. So x to the third power, if I set that equal to 0, if I take the cube root of both sides, I get x equals 0. That's one of my zeros. And since it's x to the third, its multiplicity is going to be equal to 3. So the reason that its multiplicity is 3 is because this factor of x shows up 3 times if I were to expand this out. So, if I have f of x is equal to x to the third, that's the same as saying x times x times x. That's x to the third power. That means that from this one little 0 that I get, x equals 0, I have it account for 3 of the zeros on this. That's what has a multiplicity of 3. The next one that I have is this 2x minus 3, so I take that and I set it equal to 0 and solve. Adding 3 to both sides, I get 2x equals 3. Dividing both sides by 2 gives me my next 0. X is equal to 3 over 2. Since it just has an exponent of 1, it shows up 1 time. That means it has a multiplicity of 1 for this 0. Next one, x minus 2. Now, if I set that equal to 0 and solve, I just need to add 2 to both sides. So x is equal to 2 is another one of my zeros. It's the last one. And since this has a power of 2, that means that it shows up twice, because it's the same as saying x minus 2 times x minus 2. So it has a multiplicity of 2, because it has that power of 2. All right, so this is the multiplicity and then also finding the zeros. Let's do this last part, and this is when the x-intercept is either the graph is going to touch the x-intercept. So in other words, it kind of goes into the axis and then it hits the x-intercept and deflects off, or if it's going to cross directly through it. So on a graph, it might look something like this. If it touches the axis, then that means if you have an x-intercept here, the graph's going to be going this way. And then all of a sudden it's going to hit the x-intercept and bounce right back off and keep going on. Whereas if it crosses through the x-axis, then that means that the intercept that we have right here, our polynomial might be graphed out like this, and it might hit the intercept and then go directly through the x-axis and just keep going and going and going. So those are the two options. This is where it touches the axis, and this is where it crosses the axis. So you can tell if one of these zeros is going to touch the axis or cross through it if the multiplicity is even or odd. If the multiplicity is even, then that means that it's going to touch the axis. If the multiplicity is odd, then that means it's going to cross the axis. So what I mean by even number is that if the multiplicity, these values that we just wrote down, if it's an even number like 2, 4, 6, 8, 10, something like that, then it's going to touch the axis. So all I write is touch. In my class, I have the kids write a T and then circle it. If it crosses through the axis, it needs an odd degree, not an odd degree, sorry, an odd multiplicity. And odd numbers would be like 1 and 3 and 5 and 7 and so on. So all these ones that have multiplicity of 1 and 3 are all odd numbers, so they're all going to cross through the axis. So you can just put a C and circle it. That means that it crosses the axis for each one of these zeros. The only one that's got an even multiplicity is this one over here where the 0 is 2, and that's the only one where it's going to just touch the axis and then deflect backwards. So that's what these ones are asking us to do, and that's number 11 and number 12.